Hello, welcome to my channel. Let's look at this problem and the way to solve this problem. Here you have an infinitely long resistor network. They are saying that the equivalent resistance between endpoints A and B is R. That's what they're saying. And we have to find a numerical value for R. That is the question. So in a problem like this, when you have an infinitely long network system, the first thing you have to do is to identify a repeating unit, the unit that repeats itself throughout the infinitely long resistor network. So here, if you look at the left hand side, you have a 5 ohm resistor, a 3 ohm resistor, and to the right of that you have another 5 ohm resistor and a 2 ohm resistor. So these four resistors, if you look carefully throughout the resistor network, these four resistors are repeating one after the other. So what I'm highlighting here can be considered as the repeating unit of this infinitely long resistor network. So this would be the repeating unit. Okay, so this is our repeating unit. Now, if you take one out of an infinitely large group, it's not going to change that infinitely large group. So that's the logic that we are going to use in this problem. So we are going to kind of isolate one of these repeating units, and the rest of the network as a result will not change. That means the equivalent resistance of the rest of that network will be R. It's not going to change. So with that in mind, I'm going to redraw this infinitely long resistor network. So this is how I'm going to do that. So I have the endpoints A and B, and they are saying that between A and B, the equivalent resistance is R. So that's not going to change. And then to the right of A and B, I am going to draw that repeating unit. The four resistors, 5 ohm resistor, then there's a 3 ohm resistor, like that, and then another 5 ohm resistor, and then I have a 2 ohm resistor. So this is the repeating unit. And to the right of this unit, you have this continuation of the infinitely long resistor network. Okay, now the question is, what would be the equivalent resistance of that remaining infinitely long resistor network? You can understand that it will be still R. It's not going to change. So that's the important thing that you have to understand. The To the right of this repeating unit, the single repeating unit that we isolated, the equivalent resistance of the remaining infinite resistor network is R. So that's the thing that's important when you're solving this problem. Now we have a multi-resistor network which is not infinite, and now we can use our knowledge in solving series resistors and parallel resistors to get the answer for R. Okay, so the first thing I can see is the R resistor to the right of the network and the 2 ohm resistor. They are parallel to one another. Okay, so I'm going to redraw the uh, network again so that it's clear what I'm doing. I have the 5 ohm resistor, then I have the 3 ohm resistor. This is A and this is B. And then again I have the 5 ohm resistor. And then what I'm going to do here is I'm going to have an equivalent resistance or resistor, and I'm going to name that R prime. Now R prime is the result of 2 ohm resistor and R resistor being parallel to one another. Okay, and you can get that answer directly simply by looking at the R resistor and the 2 ohm resistor. So this is how you write it directly. In the numerator, you have the multiplication of the two resistors, 2 times R, and in the denominator, you have the sum of those two resistors, that is R plus 2. Okay, R plus 2. So now if you are kind of confused how you got that, this is the theory or the concept behind it. So let me explain it using a different color. So this is how you get that. So let's say the equivalent resistance is R prime, and the two resistors, you have a 1 over R, so that is this guy, and then plus 1 over 2, right? So that is this guy. So I'm applying the concept to find the equivalent resistance of two resistors that are parallel to one another. So then you can see this can be simplified. 2 are in the denominator and R plus 2 in the numerator. But that's for 1 over R prime. So if we are solving for R prime, you have to invert this and you get 2R over R plus 2, which is nothing but, if you look at the numerator, it's the multiplication of the two resistors, and in the denominator it's the sum of the two resistors. Okay, so that's how I got this expression directly. Okay, now let's go back to solving the problem. So now I can see the 5 ohm resistor and this R prime resistor, they are in series with one another. Okay, so let's say that for that series, the equivalent resistance is R double prime. So then I can redraw this network like this. So I'll try to squeeze in the network over here and then continue it on the other slide. So I have the 5 ohm resistor over here, the 3 ohm resistor over here, and then I have the equivalent resistance of 5 ohm and the R prime resistor, which I'm going to assume to be R double prime, R double prime. Okay. Now R double prime is the the sum of the two resistors because they are in series with one another. So that is, I can write 5 plus R prime, which is 5 plus 2R divided by R plus 2. Okay. Now I am going to continue this on the other side. So let me quickly draw that figure. 5 ohm, this is A, and this would be B. And then I have the 3 ohm resistor. And then I have that R double prime resistor, R double prime resistor, which I called, which is basically 5 plus 2R divided by R plus R, right? Now I can solve that if you solve this, you have a common denominator. Here it should be r plus 2. Sorry about that. R plus 2. So the common denominator is r plus 2. And in the numerator, you have 5r plus 10 plus 2r, which is going to be 7r plus 10 divided by r plus 2, right? And then you can see the next step would be the 3 ohm resistor is parallel with the R double prime resistance. So let's continue drawing the new network, which is going to be simplified further. So these are the two endpoints. And now you have the 5 ohm resistor over there. And then I can write the equivalent resistance for 3 ohm and R double prime ohm, which are parallel to one another. Let's call that R triple prime resistor. Okay, and that's again I'm going to apply the product of the two resistors in the numerator and the sum of the two resistors in the denominator. So what are the two resistors? It's going to be 3 ohm and this guy over here, which is 7r plus 10 over r plus 2. So I have 3 ohms and 7r plus 10 divided by r plus 2. And in the denominator, the sum of the two, which is 3 plus 7r plus 10 divided by r plus 2. Okay, now I have to simplify this. So let's simplify. We have a common denominator, that is r plus 2, and on the top side of the numerator I have 21r plus 30, and in the denominator I again have a common denominator r plus 2, and in the numerator I will have 3r plus 6 plus 7r plus 10, and then you can see r plus 2 in the numerator and r plus 2 in the denominator, so they are going to cancel out, and then I will have 21r plus 30 divided by 10r plus 16. Okay, so that's going to be the equivalent resistance of uh, 3 ohms and R double prime ohm that are in parallel with one another. And so this value is the R triple prime resistance. Now, R triple prime resistance is in series with the 5 ohm resistor. Okay, so now let's call that, and what is that? A 5 ohm resistor plus R triple prime resistor, that equivalent resistance of those two will be equal to R resistor, R equivalent resistance. So then we can build up a equation. We can build up an equation. On the left hand side we have R, that is the equivalent resistance between endpoints A and B, and on the right hand side we have the sum of the two resistors, 5 ohm and R triple prime resistor. So 5 plus R triple prime. And now we can solve this. We are going to get an equation in R, and we can solve for R to get the numerical value. So we have 5 plus 21R plus 30 divided by 10R plus 16. So let's get a common denominator. 10R plus 16 in the numerator, I will have 50R plus I'm going to have 80, and then On the other terms would be 21R plus 30. So we can further simplify the numerator. So that's going to be 71. Yeah, it's going to be 71R plus 110 divided by 10R plus 16. So then we have this relationship R equals 71R plus 110 divided by 10R plus 16. And now we can solve for R, which would be like if we cross multiply R on the left hand side with the denominator on the right hand side, we would obtain R times 10 R plus 16, and on the right hand side 71R plus 110. So further simplification, 10R squared plus 16R minus 71R minus 110 equals 0. So we get a quadratic equation over here. So if we simplify this, let's see, we are going to have, what do we have? 10R squared minus 71 and plus 16. So that's going to be 55 minus 55R minus 110 equals 0. So we get a quadratic equation in R. Further, we can simplify this. So we are going to get this. I'll use a different color to put the final quadratic expression. So if we divide the entire quadratic equation by 2, we are going to get divide it by 5, then we are going to get 2R squared minus 11R minus 22 equals 0. Okay, and then this is a quadratic equation of R. We can use the quadratic formula to simplify this, and then the answer for this one is going to be R equals, you have to use the quadratic formula to solve this, which if you can't remember, I'll write it. So if you have a quadratic formula like this, ax squared plus bx plus c equals 0. So then this is called the quadratic formula expression, how to obtain it, quadratic equation of a formula. So this is how you get this. If you have a quadratic equation of this type, of this form, then the roots or the solutions would be, uh, you have minus b plus or minus square root of b squared minus 4ac divided by 2 times a. So from this equation you can get a value for x, but in our case it's not a quadratic equation of x, it's a quadratic equation of r, and when you solve it you are going to get a numerical value of 7.05 ohms. 7.05 ohms. So this is the only acceptable value for a quadratic equation. You are going to get two solutions. This is the only acceptable solution because this is the positive solution. The other solution is a negative solution, but resistance cannot be negative. So we are going to go with the positive solution. So that's going to be your answer. R equals 7.05 ohms. So that's how you do this problem.